Hello my good people. So let me show you how we can do one-way ANOVA in R. Remember, one-way ANOVA is just a statistical test that is used to check if there is significant difference in mean between 3 or more than 3 groups. So the first thing, I'm going to use the stroke data. The first thing that we do is always to load the packages. Tidyverse is always for data manipulation, Janitor for data cleaning, car package for Levin test. Now the second step is to load the data. So I look where I stored my data. Yeah, I copy the data. I copy the data. Then I come paste it in R. Then I run. Next thing is to view the structure of the data. Using the glimpse function. Yeah, you can look at the data. This now the data containing 4909 rows and also 12 columns. Among the columns we have gender, hypertension, marital status, work type, and so on. So the next step is to do the data preprocessing, which is a data type conversion. Under data type conversion, let's convert all character variables to factor using the mutate underscore if, where is dot character to be converted to as dot factor. Then we run. After running, we can now implement the one-way ANOVA. One-way ANOVA. And we can try, for example, to look at to check if there is any significant difference in mean age across the work types. So we have, for example, we have age, then we have work type. So we want to check if there is, at least if there is a significant difference in mean age across the work type groups. So you can just call it model. Remember, ANOVA is just a model. Model is equals to, the function for ANOVA is AOV. So just write AOV into bracket your dependent variable, which is age. Then you tilde with the work type, work underscore type. After that, you mention the data. Data is equals to data, like that. Then you run. After running your model, the next thing is to check for model assumptions. Remember, one of the assumptions of the ANOVA model is just the normality of residuals. Residuals should be normally distributed. Normality of residuals. Under the normality of residuals, we use the Shapiro test. So just write Shapiro.test. Then after writing Shapiro.test, we want the residuals of the model. So you write residuals, then you define your model like that, then you run. Then you look at the p-value. Remember, like I said, in a Shapiro test, when the p-value is less than 0.05, it means that the assumption of normality is violated, meaning the residuals are not normally distributed. But in any case, you notice that the p-value is greater than 0.05. That is why you conclude that the residuals are normally distributed. Now, as for this, the residuals are not normally distributed. We can also do the homogeneity of variance using the Levin test. That is the second assumption of ANOVA, homogeneity of variance. Now the homogeneity of variance is the Levin test. So we just write Levin.test. Levin test, we can use this one, Levin test. Then, of course, you just have to mention the dependent variable tilde with the work type group, that is work underscore type. comma, then you mention the data. Our data is called, still I called it data, then we run. Now we look at the results of the Levene test. You also notice that the p-value is less than 0.05, meaning that the variance, meaning that the assumption of the homogeneity of variance is violated. Remember, it always requires that we have same variance among the groups. But when the p-value is not, when the p-value is less than 0.05, it means the variances are different. So we don't make conclusions using the one-way ANOVA, but we use the Kruskal-Wallis test now. Kruskal-Wallis test. That is an unparametric test for one-way ANOVA. Now for the Kruskal-Wallis, we just write Kruskal-Wallis.test. Then of course we have just to mention the dependent variable, which is age. Then you mention the work type, work_type. Then you mention the data. So data is equals to, I called it data, like that. Then now we can make conclusions using these particular results of the Kruskal-Wallis test. Now, according to Kruskal-Wallis test, the p-value is less than 0.05. And when the p-value is less than 0.05, you conclude that at least one group is statistically significant, or the mean age across the groups is statistically significant, meaning there is a difference in mean age among the work type groups, and that difference is statistically significant. That is how to do the one-way ANOVA, and also its non-parametric test, the Kruskal-Wallis test. In case you want to learn more about the statistical analysis and all this R programming, you can reach out to me. I can assist or I can guide you.